hopefully, round 2. Hopefully this works. Now I'm on Wi-Fi. Hopefully it's a better Wi-Fi connection than what I had before. Guys, if the stream is garbage, just let me know and have some etiquette. Okay? I can't see what you guys see. All right? This is being recorded. All I see is it on a little screen like this, and I can't see the quality. That's all YouTube. It's not me. All right? Please do better. So guys, I restarted the live stream. Here we are. I just went and I made a connector. This is a jig for my regulated DC power supply. I'm using a typical bare plug, and I have 2 exposed conductors right here. So what we're going to do is we're going to use this to connect various devices to test them, to make sure that they're working. Now, I should have already had these jigs made up, okay? I should have. I didn't, with different diameters of the barrel connectors, because if you have a device that is experiencing a short or something like that, it's always easier to connect it to a regulated DC power supply. That way there you can see if it's overcurrent, and it will protect the device, and it will protect all your wiring and everything, right? It's just much safer to troubleshoot with a regulated DC power supply. Just gotta make sure you get the polarity correct. So in the last live stream, which I dropped off because everybody was complaining, especially Sean, he was being a douche. So here we are. I've got it made up. Now I'm going to switch the camera around, and I'm going to set up the regulated DC power supply for, we're going to start with 12 volts. Let's start with 12, okay? And then we're going to up it. We're probably going to go from 12 volts to, let's say, 15 to 18 to 20, 24. We might take it all the way up to 30, okay? Now, this power supply here, I think at 30 volts, it can only put out 3 amps. I don't know if that's going to be enough for this printer. We're going to find out together. So here we go. I got the jig made up. Let's go ahead and flip it around. Let's show you the troubleshooting with a regulated DC power supply, and then we're going to hook up the printer. We're going to hopefully put some life into this bad boy. Okay, here we go. Okay, guys. So here we have my regulated DC power supply. It is currently set for 4.5 volts. And I'm not really worried about current. I guess I'll turn the current up regardless because it's going to take quite a bit. So I had it at 12 volts and it wasn't turned on. So let's say 12.2. Let's see how much current it tries pulling. If it doesn't pull any, then we'll switch the polarity and see if it starts pulling some current. If it does, then we know we have the polarity correct, and we just need to increase the voltage. All right. Next, over here is the 3D printer. I have my cables coming out of the wall over here. They're connected to my regulated DC power supply. Let's go ahead and connect this guy. And connect the positive. Here we go. And I should have a better insulator to separate those two, but it's okay. Okay. I'm pulling 0.43 of an amp. Take a look at that. 0.43, 0.4. As it's booting up, I do have lights. So we are at least in the correct realm. That's good. I don't know if that's enough voltage, but it appears to be correct. So let's go ahead and take a look at this free 3D printer. And is it rigid? It's not. Okay. So this style 3D printer here, it has double arms on each of the axes, and then it's got a platter that just sits flat. Normally with 3D printers, you have a lot of problems with leveling out the plate. They made this one simple. It's designed for kids. And right here is the hot end. This is the print head. And this one here is brand new. It's never been used before. So as it prints, it's got a belt drive on each one of these axes, and it's going to go around and around and around. Then it moves up a level, goes around and around, then it goes up a level, and you get it. So it just keeps doing that over and over and over, and that's how it is going to print. Yeah. Okay, so the faceplate, the protector that goes on there. Now, it's sitting at 0.4344. Oddly enough, it didn't power up with this guy at 3 amps. Okay, well, it just homed itself. We're good. So it booted up. We have a solid ring, and it brings itself up to 0. Very cool. Okay. I don't know if it's going to turn on, and the only way for me to check that is over here with the phone, which is recording. Okay. Well, that was certainly a success, folks. And I have another 3D printer. I'll tell you what. We know that this one boots up. Oh, now it's pulling 1 amp. Okay. So you can see over there, I have a 1 on the screen. So you guys can see it has an issue though. What is okay. Anyway, I've got 1 amp. So it is operating absolutely normal. So the audio that you're hearing is probably, every time I pick it up, the microphone's probably picking up my air conditioner right there. I will try to keep it out of the airstream. All right, folks, so what I'm going to do is I'm going to disconnect the printer. That one boots up. This one has never been powered up before. It's brand new. I took all the securing bands and everything off it, so this one has never been used before. Very cool. Let me grab this second one. All right. And here is the second one. Now this one does have some evidence of being used. Okay. I've got a fan. I've got lights. And this one has a lot of plastic down here on the print head. A lot of plastic down there. I guess while that one's booting up and doing its thing, I'll show you guys one of the other projects that I've been working on. Very cool. I don't know if you guys are interested at all in CNC technology. I do a lot of that stuff, guys. I built, what, 4 or 5 different CNC machines, my own design, and they're currently, as far as I know, they're still in use at custom wood shops from California to North Carolina. I've got one in South Carolina. And now I got one that was just shipped off over here in Texas. So I've got 4 different states. I got 4 different machines that are being used in custom wood shops, and one of them is at a custom luthier, which is a guitar maker. Very cool stuff. So I normally build my own, but this time here, I guess I took the lazy route, and I don't have enough time. So I went and I bought one, and I just finished putting it all together, and I tested it out, and I'm going to do a whole stream of videos on it. So I figure, well, this guy's booting up. I might as well show you guys what I've been working on. Okay. There you guys. So this guy is the CNC machine that I've been working on. There's no dust extractor or anything because they do generate a lot of dust, but maybe someday I will. Currently I have a very small spindle. Oh, all right, that guy just homed. Okay, that printer works. I love it. So this is called the CNC machine, a computer numerical control. It's Fox Alien XE Pro, and I've got the upgrades for the linear rails. That's what these guys are called. They're square rails. Very high endurance rails on this guy. They work really well. So I'm going to upgrade the spindle in a future video. I can either control it with a hand control, like this guy here, or I can control it with a laptop, like this guy here. And with a CNC machine, I can do a whole lot of different cool things. You see my 3D control software right here. I can move it around. I can do some cool stuff. I can run a program. I have the ability to zero out my bits. So cool that that stuff's already thought out, because normally when I build these machines, I have to think that stuff out. I'll tell you, I'm just going to zero it right here. Zero the job. Yes. focus. Connect. So this is a little bit different. This CNC machine runs off of Gerbil, GRBL. I know some people call it Gerbil. I call it Gerbil. It's a simple kind of Linux style open source software. Works rather well. Connect. Connect machine. Do your job. So you have to connect the computer to the controller. Once it connects, then I can do all the magic, like move it around. I can run code. Now, what am I going to use a CNC machine for? Well, I use it for a lot of things, especially for my kids. Let's see. I have some examples of things that I've done in the past. So one of the things that I do is things like engraving on dry erase board. And by engraving, let's say me and my family were going on a trip, I'll have the kids color in the state that we're going to, and that way there they know where we're at and where we're going to go. It's a cool way to teach kids about the states and whatnot. I've also done this for currency, for coins and for dollars and whatnot. I've done it for a whole variety of different things, including cutouts for their walls and stuff. But I use a CNC machine for a whole lot of different things. It works really well. Push, connect. And for whatever reason, probably because I haven't shut it off in a day or so, my machine does not want to play well. Oh, restop. Okay, so when you have kids that come into the shop, they like pressing the e-stop. Just like when you're working on medical equipment, kids are just like nurses. They see a red button, they want to push it. Okay, machine's unlocked. And now we can home the machine. All right. So homing the machine, you guys can see it right there. It first goes up on the Z-axis, so that way there you know it's not going to be hitting anything. Then it does the X and the Y. So in 3 dimensions, you have 3 different axes. One of them is Z, which is up and down. That's your height. Y is your depth, so how far back on the platter it goes. And then X is going left to right over here. This is a tiny little spindle, but that's what it came with. I've got some other ones that I'm planning on putting in. So now the machine is homed. Let's go back over to the control software. Boop. And everything looks to be set up. And in true fashion, I drop things. So now I turn my controller on, and we can move it however we want. All right, let's do it. I actually have it set to go really slow. So this is how we figure out where our work is going to be. And you can see the first cut that I ever did on the machine, I didn't have this guy calibrated correctly, and it cut too deep. That's okay. If I was going to cut too deep, at least I did it on something cool. And this is Rose from the Sonic world, if you guys know Sonic the Hedgehog. So, yeah, I guess there could be worse things to be engraved in my bed. So what I'm going to do is I'm going to set this machine to the center point of where the work is, and then I'm going to tell it to go ahead and run. Okay, let's say right there. Close enough, good enough for government work. Now that I have the bit where I want it, now I'm going to tell it that that's the center of my workpiece. Okay. Zero's out, so it says that's 0. And since CNCs work off of math, now what I'm going to do is, there we go. Since this works off of math, once you set 0, it's going to be like +2, -3 on the Y, plus 0.5 on the Z. So it's going to be moving around in that fashion. And we have to load our workpiece. So let's go ahead, let's load our job. And let's load Knuckles. Open. Okay, so Knuckles is now loaded up on the machine and we're ready to go. And now we just say, run the job. Run the job. Okay. And the machine starts running it. Obviously, I have it floating above the surface because I don't have work down there and I don't want to destroy my machine. But you can see it's doing exactly what it's supposed to be doing. And it works fantastic. So it's a little bit dirty. So once it starts cutting, I put the flap down like so. And that contains a majority of the dust. Keeps it sanitary. So that is a rough. I'm going to do a whole series on CNC machines because I've worked on them for so long. This machine has some really cool features like closed loop stepper motors, which are very similar to servo motors. It knows exactly where it's at every single moment. And that's what it's doing. It's running the job. Okay, let's get back to it. The Yeehaw over here, it is powered up with my created power cord right here. So since it's powered up, now I would normally have to run the app, which is actually located on my phone. I'm going to have to transfer it over. And if I get this guy to run, I'm going to go ahead and do some videos on what 3D printers are. Obviously, there's a variety of different ones. And, you know, we're going to do some CNC and 3D printer videos as well. There's a lot of technology when it comes to CNC and 3D printers when it comes to dental. So if you guys are in the dental market, you are going to see 3D printers and you're going to see... Suppose stop that job. Yes. All right. I just stopped the job so it didn't sit here and irritate me. You're going to have CNC mills and you're going to have 3D printers all over the place in dental because what they're doing is traditional dental lab, they will make a mold and then they'll create a negative of the mold and they'll mill it by hand. There's a lot of like handcrafting that used to happen. Not anymore. Now they use a 3D scanner and they scan your jawline and they will create either a projected ideal tooth line or they will, you know, create your tooth line right now. So if they have to remove teeth, let's say you were going to get a root canal that maybe didn't work out so well, they got to yank some teeth out. Well, they can create some blanks that fit in there perfectly according to the teeth that you used to have. So they'll scan your jawline, they'll make you a new 3D tooth or teeth, and they'll print it out. You can pop it in and you're ready to roll. Modern day 3D printers for dental are extremely hard. They work on ceramic, they use some synthetic, extremely cool technology. So it is applicable to at least understand the basics of CNC and 3D printing. They work on completely different principles. CNC is a subtractive method, which means you take a block of original material and you remove material until you have what you want. 3D printers are an additive product line, which means that you're going to start with nothing and you're going to add material to the points slice by slice, layer by layer, until you have a finished product. So you have an additive product and you have subtractive. They're both extremely useful. I had some examples. Where are my examples? I have a whole bunch of examples of 3D printed and CNC cuts, but I'm going to do a whole series of videos on those guys. I just wanted to do a quick video to show you guys what it's like to troubleshoot with this guy. Now, it's powered up and we're at 1 amp at 12 volts. That does not mean anything, okay? When I start powering up that print head, that's when everything changes because we're at 1 amp and it's not even heating yet. I'm putting my fingers right on the hot end. It's not even trying to heat up, which is a good thing. I guarantee it's going to pull more than 3 amps. So I'm going to have to make another power supply, which is why I keep all these DC external power supplies. I keep them, a whole bunch of them down there, different voltages, laptop chargers and stuff. If you throw out the laptop, Save the charger, those 18, 19, 24 volt chargers. You never know when you're going to use them again. So I try to save these whenever possible. This is 12 volt. I still don't know why this guy here didn't power it up. Let's take a look real quick, shall we? So it's powering up with 12 volt 1 amp. This is a 12 volt 3 amp power supply, and it would not turn on. I'm a little curious, so what we're going to do is we're going to measure voltage to see, do I have any output? Am I a sucker? Because normally if you have a device that you throw out, normally the power supply is just fine. It's possible that the power supply was bad and that's why the router went bad. Who knows? Right, my meter is currently on AC. Let's switch over. Now we're on DC. Let's pull you guys in, all right? There we go. So you guys see what I'm working on. Okay. It's normal polarity according to the legend that's on the power supply. So we're going to put the negative on the outers, positive on the inner. And we have 12.3 volts. Interesting. But it definitely wasn't powering it up. Still powered in? Let me show you what I mean. Okay, we got it in frame. Yes, we do. I'm going to unplug this guy. I'm going to plug this guy directly in. It's technically the same polarity as the one that I just pulled out. So what's going on? Now, it is 2 different dimensions for the barrel jack. Now, what I'm going to do is, obviously I can't do it on this live stream because my cell phone here has got the app currently loaded on it. So what I'm going to do is I'm going to run it when I connect to it with the app, and I'm going to see if I can get this guy here to power up and run off of 3 amps. If I can get it to run off 3 amps on my regulated power supply, then I'm going to take this guy here. Since the barrel connector is a different diameter on the inside, then I will clip it and I will replace it with one of these connectors, which I have a whole bag of them, and then I will have a 12 volt 3 amp power supply. I'd feel better if it was like 7 or 8 amps. We got 3. Okay, so we're gonna run it later. We'll see if that's good enough. Then we'll try it. I'll clip this guy, re-terminate it. Maybe I'll make a video showing me doing that, and we'll go from there. Anyway, guys, it's a happy Father's Day Saturday. I hope you guys are having a fantastic day. I've got so much stuff that I've been working on. So much stuff indeed. And I know you guys normally don't see this when I'm doing streams and stuff, but I have a little clicker right here. It only goes up by hundreds. And right now, according to my numbers, I'm at close to 19,800 subscribers. We're so close to 20K. It's going to happen probably in the next week or two. But I have this guy up here to always remind me what I'm doing this for. Is you know, that there's a lot of people that take this knowledge, and hopefully I start generating some better content, guys, because things happen. Hold on, let me flip this phone around. There we go. Okay. Greg from MedStat. Okay, hold on. Hold on, let me switch this around. Okay, Greg from MedStat. I started my medical career as a machinist and 3D printer moved to Biomed. Hell yeah. There's actually very applicable. So I have my recording studio set back up. You know, it's dirty because I got a 3D printer on there, but you know, I've got a whole bunch of videos that I'm going to start doing. I've got an overhead camera that I'm going to start utilizing, and we're going to do more electronics videos, and I have some tools. You guys have been asking me to do more tool reviews. I have some more tools, folks, and one of them coming up probably in the next day or so. Boy, this guy could have really helped me out today. This is a retractable test cable set, test lead set. And I'll be doing a video and a review on these because I don't know about the gauge of the cable or the strength of the spring retraction or anything like that. I don't know any of that, right? I'm going to open it up. I'm going to do a video on it, give you my honest reviews. This would have solved my problem today because I believe that's, what, 20 foot, 30 foot, 30 feet, 30 feet of test leads. I could have left the 3D printer over here and I could have ran the cables all the way over there to my regulated DC power supply. And I wouldn't have had to move it and dirty up my bench. Retractable lead set. How cool is that? Definitely going to do that. So more CNC videos coming up. I've got a whole bunch of them, guys. I've been working on CNC for years. It's definitely a hidden passion of mine. Obviously, I got some more electronics and stuff that we're going to do. But guys, I want you guys to have a very happy Father's Day. I know that's what I'm going to do right now. I've got my kids. They've been anxious for me to do something with them. So we're going to go and do that right now. You guys have a fantastic weekend, all right? All right. Thanks for watching, guys.